Thanks, Aris. Can you guys hear me? Hi, thanks everybody for coming, and sorry for starting late. We waited for a very important person from MOH. As you know, nothing can be done without MOH support, so we do have to wait for him. So I was tossing between like waiting for him or just kickstart, but I chose the smarter option. So yeah. So I mean, thanks everyone for coming, and happy New Year, everybody. Hopefully everyone had a very restful Christmas and New Year period. So I mean, this is a journal club that we started based on the SGInnovate and SingHealth MOU, signed last year in November. And this year onwards, we were gonna have 4 journal clubs coming up. So we thought the first one, we always need to start something with trust. So we thought of choosing AI trust as the first topic, and with people from the MOH, we were going to just get them to briefly introduce themselves in a while. And we have the supercomputer, so you can't do AI without supercomputers. We have the real world example, clinician, world-renowned cardiologist here, and of course, last but not least, the one that is going to build the ecosystem all the way from undergrads, NUS chair for Biomedical Engineering School. So we have a very a world-class speakers here tonight, and it's really a true honor to have them speak. And these guys, if I don't, luckily I'm a friend. If in the industry they need to be paid like millions of dollars just to appear on the stage, so it's a really true honor to have them here. So without further ado, I will probably get the individual speakers to briefly introduce themselves, just to share your name, what you're doing, and we kickstart with the fireside chat. Yeah. So we start with Bernard. Bernard.
Hi everyone, thank you so much for having me here today. In NSCC, we are the National Research Infrastructure Platform for Supercomputing as well as for quantum computing itself. And we are very delighted to be able to support the healthcare sector, which is a very critical domain in our national strategy. And today, I hope that I could share with you a bit more about what we're going to do and how we're going to support the wider healthcare sector, especially from infrastructure as well as software stacks. Definitely, I've seen what Daniel and what SingHealth and DHS has been doing. It is really exciting journey, and we are very grateful to be part of the journey here. So maybe I'll pass it to the very important person.
Thanks for that. So Towo here. I'm from the Ministry of Health. One thing that I always talk about is when I talk about Ministry of Health is that in the healthcare sector, the center of the universe is definitely not the Ministry of Health. In fact, we play a very small part. We do see ourselves more as facilitator. A lot of the actions actually happen, at our public healthcare clusters, A-Star with a lot of research ongoing, and then the translation of research, Institute of Higher Learning as well. So really, the action is really where all these people, they are leading a lot of these efforts. What we do really is a facilitative role. So I'm happy to be here. Thanks for the invitation to share some of some of our thinking. And share some notes with everyone here. So in MOH, for data analytics, we have a team of quite diverse individuals. We have people who are trained in statistics. We have people who are trained in economics. Of course, a lot of practitioners of data science. We have people who are looking at strategy, planning, partnership. So really a diverse bunch of people. And I do believe that a lot of this diversity actually brings a lot of value, which is why that collaboration is something I'm really looking forward to. And we have been doing a lot of work together, so I'm hoping to do more. Thanks.
Thanks, Do.
Thank you. I'm Carolyn. I'm actually just the real world clinician in between the very important person and the superstar muscles. But very grateful to be here. And I think one of the first things I have to say, a great Dr. Daniel Ting fan, thank you for getting this together. This is true. It's real amazing. But I would love to bring the perspective of a cardiologist, really a clinician, accidental entrepreneur. I'm a cardiologist at the National Heart Center, professor at Duke-NUS. and really stumbled into becoming a co-founder of Us2AI, which is a company that uses AI to automate the reading of echocardiograms or ultrasound of the heart, with the whole motivation of finally automating the fight against heart disease. But thanks for letting me share my perspectives later.
Thanks, Caroline. Yep, Dean.
Glad to be here today among an esteemed panel. And good to see many friends and colleagues in the audience. I currently direct N1 and Wisdom. N1 being an interventional institute using digital AI to optimize and design clinical trials to specific patients. And then Wisdom being the Institute for Digital Medicine at the Young Lin School of Medicine, where we, again, also harness digital and other platforms, plus behavioral sciences, plus healthcare economics, plus payer side considerations to ensure that we can successfully bridge new innovations with actual adoption. Dan is a great uniter. So in the past couple of months, I've probably had social events. We've got buddies here having dinner, panels here. So he's the social chair. Glad to be here.
Thanks, guys. I'll probably just get a mic. Do we have an additional mic so that we could? Oh, there's one more mic. Okay, so why don't we actually share this little? Okay, all right. Sorry, guys. I'm not trying to hot mic, but okay. So let's kickstart right tonight. We were talking about trust, and Sto did actually share quite a lot of the MOH initiative. Perhaps you could actually share, right, based on what RE 2025 wants to do for the next 5 years, and what are some of the big plans that the ministry have, in AI and digital innovation in Singapore? Do you think we are ready yet to actually push, right? Sto, yeah.
Okay. Thanks for the question. So, in terms of our plans for AI, perhaps I can look at it across 2 different areas. One is around use cases. So we do place a lot of emphasis on use case, application of AI, because that's where it creates value. So in terms of use cases, some of the past use cases where we have implemented, it's actually quite a wide range. One of them is looking at outlier claim detection. So we started with a little pilot looking at CHARS claims. Not sure many of you are actually familiar with CHARS. It's Community Health Assist Scheme. It is a primary care subsidy that we give to Singaporeans who qualify based on the requirement, where they can get subsidy at private GP who are part of the CHARS panel. So we are looking at then the claims that are outlying claims that potentially could be non-compliant. And we use machine learning for that. So that has been done. And then we extended that after that to MediSave. Now we have a claims analytics system. It has been implemented as a system where it also covers MediShield Life. So that's one example of how it started as a pilot, and now we have a system that does all the looking at outlier claims, and that information is sent to a claims adjudication team that we have in MOH Holdings. Other than that, like COVID, for example, we have used natural language processing to look at how we can pick up ARI symptoms, acute respiratory infection symptoms, for us to see whether there are spikes, for example, of ARI cases in our public hospital, ED, and also at polyclinics. So these are some of the use cases where we have implemented. Apart from that, of course, we need to have foundational enablers in place. Enablers being the data itself, the governance of the data, and also the infrastructure. Right? In terms of the data and infrastructure, what we have done is we are bringing together data from our public healthcare institutions. So this is clinical data. We are also bringing together social data and other government data from other government agencies, putting them together into a single repository. Right now it's on premise, but our next phase of plan is to move it to cloud. There's a government commercial cloud so that we have a hybrid architecture and to take advantage of whatever good stuff that comes from cloud. Obviously, we're also looking at how we can make use of supercomputers, which is why it's important to have Bernard here. He's the man, all the supercomputing at his disposal. So that is on the enabler side. And then, of course, we have to have governance, right? To collect the data to start with, there's also a lot of fear of residual liability. Like, what if I share data with you and there's a data breach? What happens? So what we did was we brought in PDPC, Personal Data Protection Commission, working together with our public healthcare clusters because they are a key data contributor. So we brought the two parties together, where we then discussed what is the data sharing model like, who takes on what role, what is then the responsibility and accountability of each party in this whole ecosystem. Once we clarify that, things becomes easier. And we also then specify the exact legal basis for our data collection. We list down the purpose of use for the data so that there's no ambiguity around it. So those are some of the enablers we have put in place. Of course, beyond that now, AI, right? What are some of the big plans? There's a data exchange platform that's been built. We are looking at facilitating data sharing between government and non-government entities. The key one being research and eventually to industry as well. We are building it in the cloud again, in a government commercial cloud. That one with first few use cases looking at the combination of fusing of genomics data, clinical data, and lifestyle data. So that's on the sharing and exchange part. We're also looking at the development of a medical imaging platform. It is envisioned to be an open and vendor-neutral platform where they allow us to develop and deploy AI models for different imaging modalities. As to the question of whether we are ready, I think we have done very well in many pilots. We have many successful pilots. In terms of scaling from pilots to something that's operational across the entire public healthcare, I think there's still some room for improvement. And to do that, I think there are certain things that we still need to do. One example is area of data harmonization. So we look at data across different public healthcare institutions, even within the same cluster. You may find that different codes may be used. And therefore, if you want to fuse the data together, one of the first steps you need to do is really to standardize the codes that are being used, to look at then the data definition. How do we then put it all together? Ideally within the same, a common data model. What we are again piloting here is to look at the use of OMOP, observational medical outcome partnership. There's a common data model that is being used by many of our research partners. So we are looking at using that as a starting point. That may not be the only thing we look at, but as a starting point to see how we can do standardization of data to enable the sharing. So those are some of the things that I think has to be put in place. If we don't have some of these enablers in place, it's going to be quite challenging to realize our vision for AI.
Yeah, thanks, Do. I mean, that's a very comprehensive overview, right? I mean, of course, if I give him another half an hour, he can go on, right? Yeah. So, I mean, just on that questions, right? Can I ask, right? I mean, so far, MOH would have this very holistic view of standardizing the data, the platform. Now we're talking about trust, right? From a clinician standpoint, what are you seeing on the ground right now to actually surrender, say, for instance, if you have collected, say, 15, 20 years worth of data, do you see like a lot of the trust issues can be a challenge, for us to actually push forward with this AI-enabled ecosystem, so to speak, right? So, I mean, just wanted to hear your thoughts and what have you actually observed, and of course, also share some of the experience that you gained from us to AI, yeah. The journey, yeah.
Undoubtedly. Not trust,
the spot, but
trust is the key thing.
Yeah.
And my immediate answer to your question of what do you see that is the problem? It's fear, and it's fear that may not actually be grounded on anything that's real. For example, if you ask a clinician, right, what is PDPA? I can tell you that the majority of us cannot explain it, don't know the details, but fear it. And I am so grateful to hear what you said, Sitowo, or where MOH is going, because in Singapore, I really think we need a body like MOH saying it's okay, we can combine our data, we can let the data out beyond the cracks of our institution, and we're going to be secure and responsible for it. It needs to come from MOH, because my experience as a clinician and a clinician researcher, so I'm a clinician scientist who has tried to build this multi-institutional databases, the key element that took the longest time is the signing of the agreements among the institutions.
Yeah.
My last experience in a track, it took 3 years.
Oh, God.
The research, no problem, we've done it already.
Yeah.
It's the agreement among the institutions. So it just goes to show it cannot come from the research or an individual trying to, if it comes from MOH, I really think this is the way it's going to succeed. And you know what? I think it's really keeping up with the times and the way we should go. So thank you. And I mean, just a little bit about us2AI, if I may. Indeed, it got spun out from the ability to combine our databases, have this large database of echo or ultrasound of the heart, and be able to let our A-star research institutes access it to do the machine learning. So there you see, clinical information, data, top brains in our country, all working together. And it's only because of that that we managed to get us2AI. Of course, it doesn't end there. I've had to very, very humbly learn that there's a huge difference between having an algorithm and actually putting it at the bedside. Oh my goodness, in other words, creating a product. And I've been very humbled by the amount of time it takes and the multidisciplinary type of, you really, really need the business approach. You need the domain expertise. Frankly, you need God aligning all the stars for it to, keep going, get the validation, get regulatory approval, get acceptance and trust from the clinical community, and then go into usage. So
lots of things, right? I mean, she just summarized within like, the past 2-3 minutes, but it's many, many years of effort, right? Collecting the data and talking to the network of people, right? I mean, those are the things that I feel is really quite important. How Singapore is a small country, we should actually unite and see how we can actually invite more international friends to come to Singapore to do, the great thing with us, right? So speaking of the international talent, right? We have just imported someone from the west coast of, US, Professor Dean Ho, which is a close friend of mine as well. So I mean, Dean, actually, I don't think he needs further introduction. Dean has done a lot of work in drug discovery, right? The trust in patients having the medications, is somewhat actually, it could potentially be life-threatening. So I mean, Dean, can you share some of the experience you've learned so far for the past few years and some of the challenges that you have faced, and to share with the audience? Yeah.
Sure. So I would say, since we're talking about data trust, I would say what's exciting about Singapore is when we think about data being used for AI, it's not just about how much data you have, but it's how that data is acquired. So I'll give an example. An area that we work in is drug dosing. Very specifically, we've had patients who say it's a second or third line combination therapy for an advanced cancer, who appear to not respond to that treatment. Very common for the clinicians. You give them a certain line of therapy, they don't respond, and you move on. You move on until you run out of options. Using a small amount of prospectively acquired data. So the work that we do, I don't use any data from other patients to guide the treatment of the next person that walks in the room. We use only a patient's own data to manage only their own care. And so that data then has to be acquired moving forward prospectively. And so that requires an extraordinary amount of trust with the patients, with the clinicians who are administering these variable doses. That calibration that we do involves variable dosing for the patient and then measuring how they respond at these variable doses, and then dynamically changing the dose to continuously optimize their treatment. And what's important to note is for some of these patients, by simply dropping their dose of one of the drugs in their regimen, back in the day, we had work where we were able to improve efficacy. So the patient was responding, we improved the efficacy by dropping the dose, which I think at the time was quite interesting. But now we're at a stage where we're actually having patients who appear to not respond, but because of this little bit of data we get, and by modulating the dose, we switch them from non-responders to responders. So we don't change the drug, we just change the dose. So you can imagine, by the way, this is if even 2%, 3% of the patients out there who would normally be considered non-responders can actually respond, that's a lot of people. Where instead of moving on and leaving regimens behind, we can actually find more responders, and that will impact drug development, discovery, validation, all of the above. But in order to make that happen, we need an extraordinary amount of dialogue and communication with the clinicians who design the trials with us, the DSRB/IRBs, the patients, especially during this consenting process. So they're understanding that they will undergo calibration, which is all within safe ranges, all the way to pharmacists who chime back to us and say, hey, you've recommended a lower dose for this patient. By the way, this lower dose is 5 pills. If you give them a little bit higher dose, it's actually 2 pills. So then there's a pharmacoeconomics component, there's a behavioral component, and adherence component. So it takes this entire workflow in community to make this happen. And what's exciting here is I believe that Singapore has this accessibility, communication, collegiality that is unlike any other place in the world. Ministry of Health, Health Sciences Authority, all the way to our own offices within our own respective institutions who play a key role in catalyzing all of these different stakeholder engagement aspects that are critical. So it's a privilege, but again, on the topic of trust, the number of stakeholders in this process is substantial, right? But given the accessibility and the dialogue that's happened, I think some pretty cool things have happened.
Yeah, thanks, Dean. I can't agree more, right? Some of the things that Dean has actually mentioned, I mean, repurposing the drugs, and it really opened up a whole new opportunities to, in the drug discovery settings. And of course, I mean, recently, is it okay?
Iris mentioned that only these 2 are good.
Oh, only these 2 is good?
Yeah.
So I'm
we'll pass.
Pass.
Yeah.
All right. Yeah, no, just on the drug discovery part, I'm not sure how many of you have actually seen the recently announced news from London. Who in the audience, right? I mean, let's also engage the audience a little. Drug discovery, DeepMind. Any names? No, AlphaFold, spun-off technology, right? Isomorphic lab, right? I mean, that's the big thing from London, right? I mean, that's actually published, I mean, it was announced just 1-2 months ago. So, I mean, all these things actually requires a lot of the supercomputers and the GPUs and stuff, right? We know deep learning without GPU. I mean, Jeff Hinton actually described that like 30 years ago, and then the concept just couldn't fly because there's no supercomputing to support. So, I mean, with the past 10 years, right? Even like, when you go Tesla or, you go for any electric vehicles for the past 2 to 3 years, globally, there's a shortage of the chip, right? And the GPUs resources is so finite right now. And I just wanted to ask, Bernard, who's the director from National Supercomputing Centers, right? How do you actually allocate the GPU, the infrastructure and the resources, looking at there's so many clusters, IHLs are knocking on your doors and say, hey, Bernard, can you give me like 10 GPUs and 15 GPUs? How do you guys actually allocate the resources? And is there any strategic plan for Singapore as a country to get more GPUs to power a supercharged, the AI, the initiative? And I'm gonna save the quantum computers part for you later, but let's warm you up a little first, right? Do you mind sharing a bit more with the audience?
First, I would like to put the caveat. We don't use a supercomputer for Bitcoin. Now, as all of you know, technology is now at the forefront of almost everything itself. Okay, it is not just about speed and agility, but it's also about capability. Now, probably 15 years ago, what you have in your hand, your mobile phone, is this computer. Now, technology has gone leaps and bounds, and what they have created is possibility and problem. So, especially for supercomputing, it is a resources or it is a technology that allow us to be agile, allow us to scale and create the possibility and probability itself. Now, supercomputing, as you know, infrastructure, that is not cheap. And to build a supercomputer runs into millions and millions. And I'm not talking about single-digit millions, you know, could be from double-digit million to three-digit millions. Now, the idea for us is that we would like to actually democratize this infrastructure to support the key domains that has been spelled by the government itself. And obviously, the 4 domains for RIE 2025. And obviously, healthcare or personal healthcare is a very strategic area that we're looking at. Now, having said that, it also means that we do not just provide infrastructure and resources, not just CPU, GPU, and storage, and then that's it. NSCC actually is done the A star, and we work with a lot of researchers and scientists, to Caroline's point, clinician, from the clinician right down to the point that you're building a model, right now running a model, creating the advocacy. And there is a host of processes and people it takes that you need to optimize to achieve your necessary outcome. And we have been working very closely with the likes of SingHealth and NHS to see how we could bring computer science technology to the domain knowledge. You know, I was so excited when the dean spoke about how it's using AI and how they actually use it for optimizing of treatment of a patient itself. Imagine if doctors, practitioners, researchers like Caroline are able to play through the various scenarios before an operation or even before a treatment of a patient. All right. All possibilities. You guys watch Avengers, right? When Doctor Strange was battling Thanos, he played through the various possibilities, and there's only one possibility they'll win. That is not a comic. That is actually pretty much a reality. Imagine the doctors now can actually do, in a virtual environment, simulate all possibility and contingency. That does help the treatment and surgery in leaps and bounds. And that's what we hope to leverage on. Using technology, not just infrastructure, not just GPUs, but the relevant models, pre-trained models that is available. And one of the things that we hope to do is that as we actually build and use with various institutes from NUS, NTU, the healthcare providers, some of these pre-trained models will be made available to practitioners here so that they do not rebuild everything, but they could accelerate and scale. I think that will be the very interesting part. Now, from our national, as a national platform, we actually base our resource allocation is based on merits. Just meritocracy is actually in Singapore, right? Very grounded in Singapore. So it's really based on merits of the project itself. And if any of this audience here have some interesting projects, we will be more than happy to have a discussion and see how we could actually be part of your research journey itself. So I hope that kind of put things in perspective.
Thanks, Bernard. The next thing is I'm going to ask him for his mobile number, so everyone gets his mobile number so they can start WhatsApping him. And I wouldn't ask whether he actually bought the Facebook stocks as well, because he just mentioned about the very hot stuff that Facebook has just converted its name. Anyone in the audience? Do you know what the name has Facebook converted to? Meta, yeah, I heard the word Meta, right? So Meta. So I mean, like what Bernard has rightly pointed out, right? The whole world is going into a, well, I would say that this is a super exciting digital ecosystem that we are marching in, right? Metaverse, I mean, cryptocurrency, who doesn't know Dogecoin? I'm sure everyone knows what Dogecoin is. I hope everyone knows what Dogecoin is. Yeah, so I mean, Oh, by the way, that coins are useless coins, but I mean, it's backed by someone like super powerful. Yeah, let's not go into that talk. But yeah, so I mean, those are the things that the whole world, our kids would actually be growing up playing NFTs and the non-fungible tokens, playing gaming and stuff. So those are the things that's really, really crucial, right? So I mean, I just wanted to ask Sutowo, right? I mean, there's an audience touched upon just a fintech related stuff, right? AI in finance, right? So I just wanted to start going through some of the online audience. Please, there's any questions from the ground, please start raising your hand. We'll give you a mic to ask questions, right? So Sutowo, the questions is this, right? How do you see, sorry, where's the thing? Oh, all of a sudden I got a tsunami of questions right in front of me. Yeah, so earlier in 2016, the banking sector started a sandbox to experiment with AI in finance. Will we see something similar with AI and health tech, and how would it work? Yeah.
Okay, that's a very interesting question. So there are quite a few enablers that you can put in place, of which sandbox is one of those things, right? So if I don't go down to health, actually, if you look at CDPC, they have their regulatory sandbox to look at data innovation. So there is already sandbox, or there are already sandboxes that are actually initiatives led by different government agencies. In health, we have a regulatory sandbox as well.
At the moment, it is focused on looking at telehealth.
So we have a regulatory sandbox for telehealth. And why do we do that? Because in Singapore, we tend to take a light touch approach when it comes to regulation, because we do not want to inevitably stifle innovation. Because if we start off with regulation without knowing exactly what it is very dangerous. You're going to stop a lot of innovations from happening. So rather than doing that, what we do is two-pronged. First is to look at the setup of a regulatory sandbox. So we say, okay, we don't know what we don't know. Let's put a sandbox with prescribed with parameters or OB markers, right, in terms of what they can do, what they cannot do. We start to collect data to understand a bit more about the services offered. And as we collect data and understand it better and know the safety, and then we can then start to see how we can better regulate. So that's one approach. The second thing is really to look at how we work with our stakeholders when it comes to providing guidelines, best practices. One example, again, in health is we have published together with HSA, Health Sciences Authority, and IHIS, where we look at the AI in health guidelines. That guideline actually complements HSA's regulatory framework for AI&D. HSA's regulatory framework actually is targeted at commercial AI products. But we do know that there are a lot of organizations out there, health organizations, looking at building their own in-house AI models. And the guideline is targeted at that. And beyond just looking at the developers of AI, we also look at the implementers of AI. Right? So we don't just look at the people who are building, testing, and validating the model. We also look at people who are supposed to deploy it into the healthcare IT systems, providing guidance for that as well. So our approach really is light touch. For things that we do not know, we admit and recognize that we do not know. We create sandboxes to allow experimentations and for us to know it better. And we provide guidelines so that then we can help the people in the community, in the ecosystem, actually have a sense of what are some of the best practices out there.
Yeah, thanks, Doa. I can't agree more, right? I mean, the partnership, and in fact, the early partnership between the stakeholders and the government, the ministries, I think is quite important. And HSA, I certainly feel that they're actually very welcoming, right? I mean, to encourage some of the AI and innovation and stuff. And speaking of a regulatory body, and perhaps you can share some of your experience with the US FDA, when you guys are about to apply, and how's the attitude like, in welcoming some of these new AI innovations, hitting the regulatory space? Yeah.
So thanks. We got FDA approval late last year, and it
Congratulations.
thank you. And I think that applause is also in recognition of what a lot of work it takes. So what I really appreciated about the FDA was a lot of transparency. It was easy to look up and understand what they're looking for. And it's very important, if anyone is trying to do that, make sure that you have very well thought out and planned pre-sub meetings. Those turned out to be absolutely key. And don't arrange your pre-submission meetings with them until you are sure where you want to steer it to go. So I think you can tell I'm sort of bearing my soul about mistakes that I've made, because we were so gung-ho. We sort of had meetings with the FDA before I really found my muscle, okay? And so I need to get your workout plan, but going in there like a little lamb to the wolves, and sort of, it's as simple as, for us, we automate measurements. As simple as me going in thinking, oh, I can just ask to validate my measurements by simple Bland-Altmans or correlations, and totally getting, no, we want this higher standard, which was interchangeability. But not to get into details, the key is I couldn't stop I just couldn't, because I wasn't prepared enough to steer strong enough. Our predicate used Bland-Altman, but they wanted a different bar, which meant a lot of things. It meant that our validation study could not just be one gold standard reader. It had to be at least 3, because interchangeability depends on variance, and you cannot have variance with one person. You have to have at least 3 people to have variance in it. Okay, so I had to learn what the hell interchangeability was, and so it became when we finalized the pre-sub, it was a gigantuous study that we had to do, and we thankfully just decided, okay, you know what, true Singaporean stuff. I'm going to still over-deliver, and so we went to the top Echo Core Lab in Boston, get totally different studies, and took 3 readers, not only normal readers, but the top readers in the world, and met the bar. And so we're really proud of that. But I think if I had to go on hindsight, you got to know where you want to be, even at the pre-sub, and talk to people along the way. The biostatistician is your best friend. Take them out for dinner and lunch and breakfast every day. And then after that, it's really, I think, deliver the best quality ever. I'm just so proud, because you can really just stand by it. And an FDA approval, a well-done study. By the way, we're publishing it in a high level. You should hear about it soon. It's under review in a top level journal. But it gives credibility. It gives me as a co-founder confidence. Yeah. And that's what builds trust. So I don't regret it a day. I'm just saying I wish I was a bit more prepared. But I really think producing the best evidence is really the key of regulatory bodies. And very grateful that our HSA is also very, very transparent in that sense. It was very easy for us to approach and understand what they need. And it's very nice to know that in Singapore, for digital solutions like ours, you need high-level approval in 2 areas. And so we're aiming for CE mark and FDA. And then it's more or less a very streamlined and simple, straightforward process with HSA. So that's wonderful.
Yeah, thanks, Caroline, for your Chongster spirit, right? The Singapore accent. Yeah, Singapore is very proud of you. I'm very proud of you. Congratulations once again, right? Okay, so questions to Dean now, right? I mean, we're gonna go from the top ranked questions from the audience. Singapore is uniquely positioned to capitalize on deep learning, big data, and AI. The ability of orchestrate the national efforts is key. How do you think we can do this faster? How can we turbocharge this, right? Like what our Minister Ong likes to use the word, turbocharging this. How do you think we can do it?
You know, something I'd mentioned earlier was accessibility, and Satowu mentioned something, completely agree, is when you start off and think about regulating, right? I think prior to regulating, even just starting off with dialogue, like a mutual learning process is essential. And when it comes to working groups, et cetera, that's exactly what I've seen, right? When new ideas, new platforms are being developed, bringing all the stakeholders together from the various institutions, and then you know, exchanging of initial documentation of how people have designed certain trials, how they've managed their data, all of the above, to have that wealth of information shared initially prior to the regulation process or to support the downstream regulation process has been critical. So that's one aspect of it. I think that when it comes to accessibility between stakeholders, I think there are various mechanisms to do that. HSA, MOH have been very helpful with facilitating some of these initial discussions when people develop new technologies. How do you really get them off the ground? But I think beyond procedure, I think it takes a boldness as an ecosystem to recognize that for things like drug discovery, drug development, how we administer these therapies, areas that we work in, that within our ecosystem, because we have a mutual learning process when we confront the unknown, that we have a chance to rethink how these things are done. We still have that agility. We still have that agility here. If you take drug discovery, I know you'd asked that question in the beginning, Dan. So right now, pharma, it's very discovery driven, which is if you have a new molecule developed, whether it's AI discovered, whether it's human discovered, that as long as the drug is good, then whether you dose it suboptimally, or if you combine it suboptimally with other drugs, that it should still work. That's how the traditional pharma approach works, that it's very discovery driven. It's driven by the asset. But what we've already seen is that you can take good drugs, you can combine them suboptimally, and they will appear not to work. You can dose them suboptimally, and they will appear not to work. But just by tweaking the dose and not changing the drug, they work. So when you develop these drugs and your response rates are here, and if you had figured out better ways to dose it, maybe your response rate is here. And maybe drugs that don't appear as effective can be very effective. Right now, how do you build a system that is open to trying things out differently? Right? Of course, you have to manage your risk, you have to design proper trials, but you can certainly innovate how you design trials. But you need an ecosystem that is capable of that. It takes guts. It takes good regulation. It takes good discussion. But that's what I see here. And it's not kind of projection, it's what has happened. Right? And so I think that I'll give one example. I remember we had published a trial design one time, which involved interacting with clinicians to do dose modulation, a little bit more frequency of monitoring patient response. So a little bit of change to what's typically done. And I remember a major drug company in the US, one of my buddies who works there called me and said, hey, I saw this design come out. And you know, for a little bit more information, it looks like you're probably going to capture more responders. Right? And that has a profound impact on making sure that we are properly shepherding promising drug candidates forward. Again, discovery-driven considers the beginning of a drug's life, but there's still so much left to do to make sure we use them properly. And so to accelerate our ecosystem, and that's just one example, right? Medical devices, same thing, right? Is to ensure that we enact the boldness to try things differently, regulated well, designed well, but we have the numbers. We know what the success rates are for oncology. Right, we're going through a pandemic. This is our chance to consider what we've learned from decades of trials, but move forward maybe a little bit differently. So to build this ecosystem, it takes good procedure, good standardization, but it also takes a boldness to maybe go this way and try something a bit more novel.
Yeah, I think that's really true. And in fact, as just to expand a little more, are you going to share some of the COVID vaccine work that you actually done? I mean, on the
Oh, yeah, very quickly. So Bernard mentioned something
Yeah.
very cool, Avengers, right? So when you design drug combinations, it's the same thing. You take 10 drugs and you have to find what the best drugs possible are. It could be 1 trillion possible combinations because the dosing matters and which drugs you put together matter. So we have a platform called Identify. And by the way, part of building an ecosystem is also managing expectations of what AI can deliver. In our case, we're recognizing optimal combinations ranked from best all the way to worst. So we have to consider all the different variations, but we're not using pre-existing data. We're running prospective experiments. We worked with a wonderful collaborator here on live virus, beta, delta. Now we're going to do an Omicron study in about 2 weeks. And it's about providing guidance on the best ways to consider the drugs that are up for consideration now. It's not predicting which drugs can be good. Our work is different from target modeling, target identification, lead optimization. It's about what drugs do we think could have promise? And if these drugs have promise, what are some other ways we can use them? Some of the drugs we pinpointed as being pretty good, beyond just saying this is a pretty good drug, we think, hey, you know what? You might need to give this drug at a lower dose and combine it with this other drug to boost the efficacy. So it's not just stopping at drug A is promising. How do you best use drug A? How often does drug A pop up in top combinations so that in the future, when you do need a combo, how do you make sure you're advancing drug A to its next stage of use more effectively?
Yeah. Thanks, Dean. Yeah. Caroline, please.
I had a question for Dean, if you don't mind, because I'm very struck by you mentioned boldness twice and guts at least once, and and then you were talking about smart design and so on. I think Singapore has the smarts.
Yeah.
I wonder if we have the guts. And how I interpret this is, do we have a tolerance of making mistakes?
Yeah.
I really think that holds us back sometimes, that you must succeed or chop off, And it's so different when I went to Stanford Business School, where the failures are a badge of honor. That shows you've tried.
Yeah.
That shows you've been out there. And so do we, you've been from there. And when you come here, is our minds too close to potentially making a mistake here and there? It's okay. We gotta carry on.
Dean, show us the scars in the back.
So very quickly, Dan had mentioned, so I'm also head of department of NUS Biomedical Engineering. And so what's really cool about that is a chance we certainly do research in our institutes, but this is a chance to work with our future leaders in health innovation. And so one of the things when I came in as head, I wanted to look at was, are we providing the experiential education for our students so that they can try ideas out with the right partners? Can they even talk to the right partners and understand co-creation? And what's exciting is we have this recent integration with design. And today I had a chance to walk around the facilities in design, and what you see is iteration. You see prototyping, stuff that is kind of broken, laying on a table, build something, break it apart to see what is actually usable by the customer or by the clinician. And so to do this, we actually established an entity known as BME for Good, or Be Good. And what it is it allows our students to come up with ideas with community partners as solutions, but beyond a capstone design where they make a poster and present it as an idea, they actually have to develop, and Dr. James Ka, who's a gifted educator who runs this course as part of the Be Good entity, we have them develop prototypes, and they have to also think about prototypes that can advance to manufacturing stage. And now with our design colleagues, we have interaction design, industrial design, to make sure that we're asking those questions early on. Is what we're making useful? And are we asking the right questions? Are we making enough things and breaking them apart to make sure we've got a chance to actually change practice? And so we're using Be Good as a gateway to introduce our community to that grit and to those challenges up front. And the final thing I'll say is unmet medical needs. I think certainly addressing an unmet medical need is vital, but there's so much after that has to be addressed. And that's what we're aiming to do with the Be Good entity. We're starting with our future generation.
Yeah, I think that's a good initiative. I mean, in response to what Caroline has asked, I think this is what Singapore needs, right? All the undergrads, they need to learn how to fail fast, celebrate failure, batch of honors, and and of course the school ecosystem is really allowing them to do that, right? And this leads me to the next questions, right? Bernard, you're up, right? I promised to actually ask you these questions just now, the quantum computing, right? So, I mean, there's one question that asked about the challenges of creating a trustworthy AI environment for healthcare. With all these GPUs, the fintech, we talk about cryptocurrency. Now we are looking at the next generation types of supercomputers, which is the quantum computer. What are some of the cybersecurity risks, right? I mean, we talk about trust within the human settings. We also need to actually consider some trust within the digital ecosystem settings, right? How do we protect ourselves, right, with all these newer generations of the hardware computing coming to the market?
Well, when it comes to trust for AI, I think it's not just about trust in data, but it's also trust in the process as well as the technology in place. Now, obviously, I can't talk about the part on the data. There's more for language expertise. But from a technology point of view, we are actually embarking on several fronts. And one of the very interesting front is basically how we can keep data safe and yet shareable. Example would be quantum key encryption, how we use quantum mechanics and physics to have I won't say unbreakable code, but the ability to secure data transmission from end to end is going to be key of that business. Another very exciting project is what we call homomorphic encryption itself, whereby you are able to have encrypted and yet you could actually do the research and computational capability without decrypting. Those will enhance the trust that we're going to have in place for that business. Now, having said that, I think this is also a very interesting topic of ours that we need to work with the respective regulatories. How to actually make some of this technology readily available itself. But having said that, I think one of the critical points here is that trust should not be in this kind of environment where people could accelerate and develop innovation. And that does take a lot of guts. Now, in terms of security, and there's always going to be an attack. I don't know where, and I shall not name where they're coming from. But I think that should not stop what we're trying to do. Now, in Singapore, I would say we're very small, but at the same time, we're very organized and coordinated, just like the National Supercomputing Centre. It is actually born out of the need to provide supercomputing capabilities to all in advance. We don't build now. We plan and build for the future. And therefore, in the future, we do see explosion of data. We already see explosion. Every day we are seeing almost 3 to 4 exabytes of data being produced. How can we use such data effectively and yet in a secure way? These are key questions that we are answering right now, and that should be part of the overall ecosystem that Dean has been talking about, whereby the talents, the data, the domain experts, the technology, and the various AI platforms that's available is readily available to everyone to innovate. Pardon me, but I always believe, like, especially in the world of AI and ML, gone are the days that you need a master or PhD in computer science. Anybody can write a program, anybody can create a model, anybody can commercialize it. It is all about creative innovation. And And if we have all the tools in place right now and all the infrastructure readily available for them, what's stopping them?
Thanks, Bernard. I mean, I think this is a very important point, right? I mean, going back to the initial point that you said, how do we democratize AI? How can we make AI more widely available? And in fact, like you say, right, we were just talking about this thing called auto machine learning platform, right? Someone with no coding experience, if you go to sign up for Amazon platform, so long as you have the data sets, you can actually build your own algorithm right now. So this is the types of the machine learning, like, you know, the digital ecosystem that we are actually marching towards right now. And I just wanted to also just ask one of the audience questions, right? Have any one of the panel here seen AI being abused in health? I mean, either in Singapore or overseas, right? Very interesting questions, but I just wanted to open to the floor and see, anyone have such experience that you guys can share? No? I suppose this is a very I suppose MOH, we probably need to take Sutowo to another platform to ask him the same question again. Probably we can hear some, you know, some news. Yeah, but I mean, yeah, okay. So that's heartening to know. So no, I just wanted to, and yeah,
Can I just add one point? I came from Red Hat, and Red Hat is an open source company. And one very interesting idea that I learned from Red Hat is how you actually grow as a community. Example for even for AI, how can we actually create a no boundary open source AI that everybody can utilize, build on top, collaborate, and advance the entire community. And there's this a community called open source community. It is a place where everybody would give their input and better build models on that basis. If we ever, from a healthcare perspective, able to create such open community, I think it will help to accelerate Singapore's healthcare sector itself. Really.
thanks, Bernard. Yeah, so
The question that Daniel has earlier, I'll share a little bit, but for more details, maybe ask me after. After I have my alcohol.
Where's the whiskey?
Views of AI, right? But rather, I think something we need to be very mindful of, because typically for someone who is a practitioner in AI, there's a lot of focus on the technical performance of the model, right? Look at precision, look at recall. If they are good, then they must be good, right? Then you go ahead and implement it. But real world implementation could be very different, because as part of our work, we do program evaluation. And one of the programs that we evaluate at the ministry level is where we try to, there was an implementation of a hospital readmission model. The whole idea is that there are people or patients who are being readmitted again and again. If we can identify them in advance, we will then be able to provide the support needed for them, hopefully let them stay well at home in the community rather than being readmitted to the hospital. So technical evaluation, all good, implemented. But when we look at the data, we realize that readmission rates actually increase in some institutions. And we have to drill deeper to understand why. So I think it's important to go beyond the technical measures of how good a model is, to look at the business indicators, the clinical indicators. I think those are very important. Some of these things, they are unintended consequence of certain programs that you run, the way people see the program, the human behavior that comes with it, how it's being implemented, all could affect the result or the outcome that you get out of the program. So I think it's a useful reminder to not just look at the technical aspect, but to look at the clinical and the business aspect, so that then we don't lose sight of these things when we do implementation of AI.
Thanks, Udo. I think, you mentioned, I think I just wanted to highlight to the audience about this term called the intended use environment, right? I mean, this is where the business case. So US FDA, if you look at the SAMD guidelines, you will see this word called intended use environment. In many of the lectures I give, I literally will mention this word like probably 4 or 5 times, right? It's really, really important to be very, very specific. Where exactly do you want to use your algorithm? Is it in the population-based setting? Is it in the tertiary-based setting or quaternary setting? Where do you want to use it, right? I think that's very important. And second thing that I also wanted to highlight is that not so much about abuse in health, but how do we protect ourselves, right? I just wanted to also introduce a few concepts, that I'm sure like a lot of the people here have also experienced with adversarial attack, right? I mean, this is something that the electric vehicle space are very, very concerned about, right? Just imagine if today you're driving a driverless car and someone injected some noise into the stop sign and your driverless car has actually detected that instead of the stop sign, it becomes a go sign, right? So this is in the technical term, we call it AA. So, I mean, we haven't really seen many of these incidents happening, but we do need to actually kind of prepare ourselves from all these cybersecurity, the potential threats that's going to hit the space, right? So the EV, if it can happen. So, I mean, some of the things that our lab is doing right now is to see how can we create such virus, infect the medical images with such virus, and how do we protect them using some defense system. So this is concept number 1 I want to just to share, right? Secondly is the use of blockchain. Can we use blockchain to regulate some of the AI transparency? Can we actually improve trust? We actually published a paper last year in Lancet Digital Health to see how we could actually use such platform to the immutable platform, right? So anything that you publish in the platform, you'll be logged as a hash values in 25 to 30 alphanumerical values. If you have logged in 10,000 images, if you change one image, the whole entire hash value will change. So potentially we need to start exploring some of these areas to see how we can improve the trust and transparency for AI solutions. So those are the things that I just also wanted to kind of share a little. Not sure whether the panel has any other, the thoughts or suggestions. Very cognizant about time. We have 8:15. Any question from the audience? Sorry, we've been addressing a lot of the question from the online audience. What about the physical audience? I mean, very heartening to know I haven't seen anyone,
You're all just waiting.
dozing off. Oh, everyone is just waiting. Any questions from the audience? Jose, David, Henry. Yeah, Jose, yeah, please.
Posed the question, it was just something that came up in a personal life. You actually always say like, oh, everybody can program, you just need a data set, but of course, the data set contains patient data, and they may not have always consented to be used by everybody in their added programming away. Like, what are your views on, I guess, everybody's very data hungry, everybody's very enthusiastic about the applications, but of course, it is still patient data. Maybe you want to use it. Maybe they have consented to using it for their diagnosis or for some prognosis, but they may not have consented to staying in the system and becoming part of the data set that everybody is using. What are your views on maybe dynamic consent or maybe in that area for keeping patient trust?
From ministry?
First, if you look at the way PDPC has looked at it, consent is required if you are looking at identifiable data. You're right, there has to be consent has to be sought, and usually it's express consent. There's this concept of deep consent. However, most of the time, in fact, almost all the time, when you are looking at AI, machine learning, you do not need identifiable data. And in fact, we only use anonymized data or de-identified data, right? And there are also other techniques like what Bernard has mentioned, right? Homomorphic encryption. So there are ways in which we are protecting the privacy and the identity of the people whose data is being analyzed and being used, say, in AI or machine learning. So I think that that's a very important thing, and that governance of who can access what data, what is the approval process that someone goes through.
Yeah.
That's why I mentioned, in order to make the data sharing work, we have to be clear about the legal basis for our data collection. Why are we collecting the data for? Like for the ministry, we can of course also utilize public interest, but of course the bar is very high when it comes to public interest, right? Not everything is public interest, and we try not to use that unless absolutely necessary. So there are safeguards available from the legal perspective, from the way, the technical protection of the data, whether in the area of cybersecurity or the data security side. I think there are many things that we can do, and we don't necessarily have to then go into the identifiable data, which I think actually, if I were to contribute that data and people will look at it in identifiable form, I will be equally uncomfortable as well. Thanks.
Thanks, Do. I just wanted to ask, I think Jose actually brought up a very good point, dynamic consent, right? The data that you consented for initially may be used for other purpose next time. And when you exceed a certain number, say 100,000, first is how practical it is to go back to the 100,000 patients to retake the consent. But if you don't do that, how ethical it is to actually, so that actually is a very hot topic in AI ethics right now, right? How do we, gain enough consent to use the data to actually build algorithms? And once you build the algorithms, do they own it? Do they have a piece in the pie to actually share the revenues, right? So those are the very, very important, the AI ethics questions that's slowly emerging, in the space. I'm not sure, Caroline, Dean, or Bernard, you guys have any, comments on this?
So we need Ministry of Law.
Yeah, sure.
Oh, yeah.
Yeah, so we, in the context of genomics data, which I think is highly personal, and it has a lot of implication because unlike other data, right? If I have my health history, for example, maybe one medication I take for acute episode may not matter that much in terms of, let's say the unfortunate event where my data is lost. I think the impact on me as an individual will be less as compared to genomics data, which is really something that I'm going to carry for life, and people knows about that, right? So there's a lot more, it's a lot more sensitive to an individual. And we did some consultation with members of the public, trying to have a good cross-section of the public, different segments of the population. And there were a few very interesting findings from there, right? One is that people are willing to share data for greater public good, as long as it is not accrued to a small group of privileged individuals or to benefit certain organizations, or especially for-profit organizations. So I think that's a very important point. People are willing to share data, but for greater public good. They don't want it to be in the hands of some monopoly or some for-profit company making tons of money out of their data. So I think that is an important thing to keep in mind. A lot of us are quite altruistic, but we also want to prevent the abuse of the use of our data.
Can I just, if you don't mind, just add on to what Stuart just said, all these safeguard leaves has to be planned in advance to ensure that all these are being taken care of. And I believe technology could play a pretty significant role here. It may not solve our problem, but it does play as a safeguard levers. HE to content encryption. If there is a proper procedure that we are planning in advance, then that does help a lot in terms of the trust and addressing one of the attendees' concern. So I think that's something that we're more than happy to collaborate with you in the near future.
I just have one futuristic dream to help Jose to solve her concerns, right? just imagine if today patient is the one that owns the data. Today we can tokenize the data, right? If today we can build a platform that actually has request and approval system. Again, I don't want you guys to think I'm like a blockchain freak, but this is the only way that you can actually circumvent around this thing, right? So how do you create multiple millions and billions of nodes through a blockchain platform so that patients themselves have the autonomy to actually approve or deny the data request for the future use of the AI solutions that's going to be built based on all this data, the patient's data. It's something, no right or wrong answers, but I just wanted everyone to actually just digest a little. Because for my kids, for my grandkids, right, I always would want to fast forward the society to 15, 20, or 25 years later. What is the world going to look like, right? I mean, am I still going to surrender my data for others to use, or do I want to own my own data, right? This is again another big ethical question that we can save it for the next journal club. With this, I would like to end this session and thank you everyone for coming here. Thanks very much.